Heyo team, apologies for not being here of late, but alas, we're going to get straight on into it with some 10A and 10B notes, and we'll chat when I return. So this is going to be unedited, so hopefully it goes alright. So for 10A, what we're looking at is the equation of the tangent. Or a tangent line, we're going to say. Now, previously what we've been doing, right? We've obviously been doing differentiation, we've been doing calculus and all that jazz. But what we've been specifically looking at, right? What we've been specifically looking at is the gradient of the tangent. Okay, so we've been specifically looking at the gradient of the tangent line. And if you recall how we find the gradient of the tangent line, let's say at x equals a. Okay, to find the gradient of the tangent line at x equals a, we simply find m equals the derivative at x equals a. Okay, so let's put that in a light example just to recap us. If we have y equals x squared, okay, just a very nice, easy example, and I want to find the gradient of the tangent line at, and I'm going to say the coordinate 2, 4, and you'll see why I'm using this in a second. So the gradient of the tangent line at 2, 4. Okay, so the first thing we need to do is find the derivative. Okay, so dy dx. Okay, this derivative shouldn't be too bad here. Take the power down, so the 2 out the front, and then drop the power by 1, so we just get 2x. Now, if I want the gradient, okay, if I want the gradient here, I'm now just going to plug the number 2 into my derivative, right? I'm just finding the derivative at x equals 2. Okay, so I do that here, and I get m equals 4, right? So this is pretty straightforward. Everything we've done so far has kind of been this exactly, right? So the gradient of the tangent line at x equals 2 is 4. But now what I specifically want now is I want the equation of the tangent line. Okay, so let's sidebar for a quick second here. What is the tangent line? Okay, very curved here. Clearly I haven't laid out my board very well, but alas. I'm going to draw myself in a quick little parabola here. How do I get different colors? Draw, add, pen, blue. Okay, and I'm going to draw a nice little parabola here. Okay, and I want to find the tangent line at 2, 4. Now remember, when we're finding the tangent, okay, the tangent to a curve, it is always a straight line. Okay, it's a straight line going through that point, or more specifically, touching that point exactly once. Right, so it's a straight line that touches that point. So if it's a straight line, think about what the equation of a straight line is. Well, of course, the equation of a straight line is y equals mx plus c. So pretty much all we're doing is we're now taking it one step further. We found the gradient of the tangent line, but now we're just putting it into the form of a straight line equation. So I'm going to take this 4 and plug it in as my gradient. So I get y equals 4x plus c. Okay, so a very basic straight line equation. Now all I need to do is find c. How do you think we find c? Well, back to like chapter 1, 2, 3, everything we've done since year 11, we now just go and grab the coordinate, right? We grab the coordinate 2, 4, and we plug it straight in to find c, right? Like we've been doing with every single mathematics thing we've been doing. So 4 equals 4 brackets 2 plus c, right? Just plug in 2, 4. Okay, Now we'll just do the quick algebra in here. So 4 equals 8 plus c, take the 8 over, and we get c equals -4. And so what we can see here is the equation of the tangent line. Not just the gradient, but the equation of the tangent line is equal to y equals 4x take 4. Okay, so that is the equation of the tangent line to the curve y equals x squared, going through the point 2, 4. Okay, so it's very similar to what we've been doing. Previously we found the gradient, now we're just taking it one step further and finding the full straight line equation. Okay, so hopefully that isn't too bad here. So let's do another example of this. We're going to do y, I'm actually going to go f of x, apologies if you already wrote y, equals sine of x at x equals pi on 3. Okay, so this is what I'm going to look at here. Okay, and I want to find again, find the equation of the tangent line at x equals pi on 3. Okay, so I'm finding the equation of the tangent line to f of x at x equals pi on 3. Okay, so the first thing I might want to do is find, of course, the gradient of the tangent line. Okay, so let's look at the gradient first. Gradient. Okay, so to find the gradient, I, of course, take the derivative. Okay, gradient means essentially derivative. They're all sort of one and the same. Recall back to last term and hopefully recently in the holidays. The derivative of sine of x is cos of x. Okay. But now we want to find the derivative at x equals pi on 3. Okay, so now I'm going to do f dash of pi on 3 because I want to know the gradient at this exact coordinate. So that's going to be cos of pi on 3. Okay. Going back to your exact value table, if you haven't got one accessible, it might be worth after this video to actually writing yourself an exact value table. But cos of pi on 3 should give you a half. Okay. Now in my blurry 6 state, if that's incorrect, just fix it in your own pages. You know what you're doing. Okay. So we know the gradient is a half. So we got y equals a half x plus c. This is now going for the equation. Okay, so we found actually the gradient up here, right, m. And now we're going to find the equation. Now to find c, we need to plug in a coordinate. But there's a little bit of a problem here, right? We have y equals a half x plus c, but we're only given the x coordinate. Okay, we're not given the y coordinate. So how might we solve that problem? Well, we still have f of x. So if I want the y coordinate, okay, I'm just going to do f of pi on 3. Okay, so I'm still just doing normal maths here. I'm simply plugging in the x coordinate to find me the y coordinate. Okay, so that's going to give me sine of pi on 3. Okay, and sine of pi on 3, that should give me root 3 over 2. Okay, again, if I mix those two up, I do apologize. But we're going to get the coordinate of pi on 3, comma, root 3 over 2. Okay, now we have the coordinate. We can go back and plug that into the equation to find out c. So we're going to go root 3 over 2 equals a half pi on 3 plus c. Okay. Now with these, you may still get quite weird plus c values. And I know it seems like I made this one up, but I actually think I pulled this from the textbook. So they do actually give you quite strange values, but it's completely okay to do this. So I'm going to go root 3 over 2 equals, and I'm just going to times the tops times the bottoms here. So pi over 6 plus c. Then take the pi on 6 over, so root 3 over 2 minus pi on 6 equals c. Now I might go one step further here and make them the same denominator by simply times 3 times 3. So I get 3 root 3 minus pi all over 6 equals c. Okay, so now when I get my full equation, I get y equals a half x plus 3 root 3 minus pi over 6. Okay, so this is the equation of the tangent line, right? So again, find the gradient by just finding the derivative and plugging in the x value. Plug that into the straight line equation, y equals mx plus c, and then plug in the coordinate to find c. So that's all there is to the tangent line. So a lot of it is very similar to what we've been doing. We're just taking it one step further and using the straight line equation. The next thing we're going to look at is the normal to the curve. Okay. The normal to the curve. Now, this is, again, very, very similar. What we're looking at, okay, if I have a much straighter, ideally, there we go, a much straighter Cartesian plane here, y and x there. I'm again going to draw in my parabola for a curve. Okay, looks almost more like a quartic, but that's okay. And let's look at the point, again, 2, 4. Now, the tangent to the curve is this straight line here. Okay, tangent. Okay. Now, what we're looking at here is we're looking at what's called the normal. Okay, the normal. Now, this is almost a physics terminology here, but when we say normal, all we're meaning is perpendicular. Okay, so I'm looking at this guy here. Okay, so I'm looking at normal to the curve where they meet at this right angle. So whenever you see normal to the curve, you almost think perpendicular to tangent. Okay, that's all that the normal is. Okay, if we remember back to, I think, chapter 1 or chapter 2, when we're looking at perpendicular lines and straight lines, we know that m norm, okay, or m perpendicular, is equal to -1 over m original, or m tangent. Okay, so the gradient of the normal is equal to -1 over the gradient of the tangent. Okay, so you don't actually do anything crazy here. You simply find the gradient of the tangent, and then you just do -1 over that to find the gradient of the normal. Okay, so we're going to take a look at this example here. We're going to look at y equals x cubed minus 2x squared. And we're going to find the equation of the normal to the curve at, and we're going to look at 1, -1. So I'm actually giving you the coordinate here. You don't have to find the y value here, which is quite nice. Okay, so the first thing I'm going to look at is I'm going to find m tan. Okay, so I'm looking at the gradient here. Now, the reason I'm not jumping straight to m normal is, well, because we don't know any sort of key rules for m normal. We know how to find m tan, and that is simply just f dash of x at that point, right? Or the derivative. So the gradient's going to be 3x squared, take 4x. Okay, hopefully that derivative isn't too bad. Drop the 3, drop the 2, and just multiply them in there. Now, if I'm looking at f dash of 1, okay, plugging in that x value, it gives me 3 minus 4, so -1. So what I've got is the gradient of the tangent. Gradient of the tangent is equal to -1. But I want to find the equation of the normal. So I'm going to go m norm equals -1 over -1. Right? -1 over the gradient of the tangent. And that just gives me simply +1. Okay, so the gradient of the normal is simply +1. Now I'm going to scroll back up to my picture. Now the normal, which I probably should have written this in here as well. Now the normal is still a straight line. Okay, it's not a curved line, it's nothing like that. It is always still a straight line. So when I go back here, I'm still going to go and have y equals 1x plus c. Okay, because I'm still looking at y equals mx plus c. Okay, and just taking that 1 from above. Okay, the next thing I need to do is plug in a coordinate. Scrolling back up, well, it still passes through 1, -1, right? Again, looking at my picture here, this picture still passes through 2, 4. It doesn't go through a different point here unless it specifically tells me. It's still going through that same point, right? The tangent of the curve at a specific point and the normal of the curve at that same point, of course, go through the same point together. So I'm just going to plug in 1, -1. Okay, so let's quickly do that here. We're going to get we're going to get -1 equals 1 bracket 1 plus c. 1 times 1 is just 1. Minus it over and we get -2 equals c. So we get y equals x take 2. Okay. So the gradient of the normal and the gradient of the tangent are very, very similar, okay? But they will give different answers. Okay, they'll always give different answers. But all you need to know is that the gradient of the normal is perpendicular to that of the tangent. Okay, let's do one more complex example of this. It's going to be quite a complex looking one, where we're going to find the gradient of the tangent and the normal together here. So we're going to find and the equation, the tangent, and the normal to the curve. I'm gonna be testing your derivative skills here by giving you quite a complex sort of thing here. It doesn't look nice, but it does the job for what we want it to do. So we're going to do 3e to the x squared plus 4 minus x plus 3 over x take 2 at x equals 3. Okay, this here is the question. A few seconds to write that down. Hopefully we're all pretty okay now. Okay, so we want to find the gradient, we want to find the equation, okay, not just the gradient. We want it of the tangent and the normal. So we're going to be doing a couple of different things here. Okay, let's do the first thing here, and let's find the gradient. Okay, let's find the gradient. Okay, and we're going to find the gradient of the tangent first, because of course we don't find the gradient of the normal first. It's just, it's a little bit more inconvenient. Excuse me. All right, so gradient of the tangent means we have to find derivative. So this is where I'm testing you a little bit here. How do we find the derivative of this? So let's break it down. Okay, let's look at the first chunk, and that's the e chunk here. And let's look at this chunk here first. The derivative of e is just e. Okay, so we still have the 3 out the front, that hasn't been touched. Then it's just e. Okay, nothing changes yet. But then what we've actually got here is this is actually a chain rule, right? It's a function of a function. The x squared plus 4 is that baby function. It's inside here. So now I'm going to have to times by the derivative of the top there. So just 2x. Okay, so the derivative of e to the anything is just e to that same thing, nothing changes. But then I have to multiply by the derivative of the inside. Now looking at this second part here, I'm still just going to leave the take out the front here. I'm going to actually put it in brackets so I can deal with that. Now this second part here, it's a fraction. Okay, this guy here is a fraction. What rule do we use for fractions? Well, of course, we use the quotient rule. Now, memorizing the quotient rule, I believe you remember me saying this. You do not have to memorize. I don't even have it memorized because it is on your formula sheet. So I'm going to drag this, this formula over here. Hopefully we can all see it. And look at the derivative of the quotient rule. It's in there. So when we have it like this, okay, so the v is the bottom part. Okay, remember it's the derivative of u over v. This one isn't exactly as pretty as it should be. But the derivative of u over v, we do the bottom one times the derivative of the top. Okay, so let's do that first. So let's go back over. So we're going to do the bottom one, v. So I'm going to do x take 2. Right, this is like our u over v. Okay, so we're going to do the bottom one, x take 2, and we're going to times it by the derivative of the top. And that's just 1. Going back over to the formula here. Okay, then we're going to take away the top one times the derivative of the bottom. So we're going to take away the top one, x plus 3, times the derivative of the bottom. Okay, and that's just 1 again as well. And then we're going to do it all over v squared, or all over the bottom squared. Okay. So that there is our derivative, but we're going to try and make this just a little bit prettier because we are practicing our derivatives as well. So let's group up that first one to just be 6x e to the x squared plus 4. Okay, just joining the 2 and putting the x at the front. Now I'm going to tidy up the inside in here. All of this times 1. That times 1 doesn't really matter. Okay, so we can kind of get rid of that. Then we've got an x, take away an x, so that gets rid of each other. And then we've got a take 2, take 3. Okay, so it's going to be a take 5. Over x take 2 squared. And finally, the negative and the negative cancel to make a positive. So 6x e to the x squared plus 4 plus 5 over x take 2 all squared. Okay, so this is f dash of x. So this is the derivative. Okay, so to find the gradient. Okay, to find the gradient now, we're going to plug in this x equals 3. So I'm going to do f dash of 3. Okay, so plugging that in here, I'm going to get 18, right? 6 times 3. Yep, sorry, I made a mistake on my working out. This is all fine. What you've written is all fine. I just made a mistake on my own personal working out. Yep, so 18 e to the, and then we've got 3 squared is 9, plus 4 is 13. Plus 5 over, now 3 take 1 is 1, 1 squared is 1, 5 over 1 is just 5. So that here becomes our gradient of the tangent. So this is gradient of tangent. Okay. Now while we're here, we might as well find gradient of normal. Okay, the gradient of the normal. And that's just going to be negative 1 over this whole thing. Okay, so I'm not going any further than that. I'm not trying to simplify it. I'm not trying to make it this whole weird heebie-jeebie thing. I'm simply doing negative 1 over it. Okay, so now I find the gradient of the tangent and the gradient of the normal. So I'm going to make 2 columns here. I'm going to do, let's do tangent equation. And in the second column here, I'm going to do normal equation. So I'm going to get y equals that big heebie-jeebie gradient here, 18 e to the 13 plus 5, x plus c. And the normal over here is going to be y equals, maybe I'll do it in green here, negative 1 over 18 e to the 13 plus 5 x plus c. Cool. Now, we need to find c. Now, I actually didn't find c for the normal in my working out, so it's up to us if we decide to do it. Let's see how we go. But either way, to find c, we need to plug in the x and the y coordinate. Let's scroll back up for a second. I've only given you the x coordinate. So what do? Well, we plug it back into the original. Okay, we're going to just find f of 3 here. Okay, we're going to have to find f of 3 here. Apologies if your book doesn't allow for this nice working out here. But f of 3, when you plug it in, okay, just gives you 3 e to the, and again, 3 squared plus 4, so 9 plus 4, so 13. Minus 6. Okay, because we did the 3 plus 3 is 6, and the 3 minus 2 is 1. 6 over 1 is 6. Okay. So our coordinate is 3, 3e to the 13 minus 6. Okay, now we have our coordinate. I'm going to cheat here. I'm going to lasso select this. Maybe. Perfect. I'm going to copy it. Oh my goodness. Not working as well as I hoped. Copy it. Paste it down here so we can see it. Excellent. So, let's try do this. So I'm going to plug in 3e to the 13 minus 6 equals 18 e to the 13 plus 5 times 3 plus c. Okay, let's try work this out. Left hand side doesn't change. Expand that 3 in, so 18 times 3, 36, 40, 54. E to the 13. I much prefer being at school where you guys can actually tell me 18 times 3. Much hurts my head a lot less than me trying to work it out myself. Right, now I'm going to take the 54 e to the 13 and the 15 over. So I'm going to negative 51 e to the 13 minus 21 equals c. Okay, so writing this out neatly, quote unquote, 18 e to the 13 plus 5 x minus 51 e to the 13 take 21. So this is quite an ugly equation, right? But the point I wanted to get at is this can be done with every single type of derivative. Okay, it can be done with e's, logs, circular functions, fractions, etc. The idea is just take the derivative, use that to find the gradient of the tangent. Negative 1 over that gives you the gradient of the normal. Then you plug it into y equals mx plus c and you're happy days. Now on the right hand side here, I'm not actually going to work it out. But what I'm going to do is I'm just going to show you what we needed to do. So we plug in the same y coordinate. Okay, same thingy here. Okay, then realistically you could have just gone straight with the cas here. But it's just a matter of taking it over and happy days like so. Excuse me. So, gradients of the tangents, equations of the tangents, gradients of the normals, equations of the normals. Nothing really is that new here. It's just a matter of applying what you know into a more equation-based scenario. Okay, so that's all of 10A. Now, I am actually going to do 10B as well. And the reason is because there's literally one example. Okay, and it should be quite small here. It's honestly a little unrelated. But because I'm not here, and hopefully this should wrap up in less than a period, this should give you a bit of stuff to work on. Right, so 10B is all about rates of change. Okay. Now, I actually think we have talked about this before, but all it is average rate of change okay, the average rate of change, that equals to f of b minus f of a over b minus a. Okay, so essentially like the gradient. Okay, so it's the same thing as what we've been doing for gradient. Average rate of change, I think we did talk about it before. Now again, I think we've talked about it, but instantaneous rate of change. Okay, instantaneous rate of change. Well, average rate of change is over sort of like it's spread out. Okay, it's over 2x values. Instantaneous is exactly at one value, so it's just the derivative. Okay, so I'm going to say f dash of a, and I'm going to just put in brackets at x equals a. Okay, so the instantaneous rate of change is just the derivative at that point. Okay, a quick example of this, and this is the last thing before I let you guys try some questions. We're going to look at f of x equals x squared plus 2x. And part A for this question is going to be find the average rate of change over 2 to 3. Okay, find the average rate of change over 2 to 3. Okay, so that's just A, B, and so we're going to do average rate change equals f of 3 minus f of 2 over 3 minus 2. Now the order of this doesn't matter. Okay, you could have done f of 2 minus f of 3, as long as on the bottom you match that up to be 2 minus 3 then. Okay, f of 3, that's going to be 3 squared plus 2 times 3. And I'm going to put it in brackets here to make sure that I'm taking everything. 2 squared plus 2 times 2 over, and 3 minus 2 is just 1. So we can get rid of that in the next step. Okay, so we got 9 plus 6, so 15, minus 4 plus 4 is 8, and that works out to being 7. So the average rate of change over 2 to 3 is 7. Okay, my voice is reaching its end, so luckily we are nearing the end here. Part B, we want the instantaneous rate of change. And we're just going to pick x equals 2. Okay, so what that is just find f dash of 2. Okay, to find f dash of 2, we need to start with f dash of x. Looking back at the equation here, hopefully that derivative is pretty straightforward. It's just going to be 2x plus 2. So now f dash of 2 here is going to be 4 plus 2. Okay, 2 times 2 plus the 2 there. So 6. Okay. So that's all of 10b. Okay, I know there's not a lot in there, but it is honestly rather straightforward. 10b I think is quite easy. Well, not easy, but straightforward. Okay, and I think 10a is more application based and more tricky. So when we're working through for the rest of today, I think we have a double today. And if you manage to go to Beat Maths tonight, I know I won't be there, but please still make the most of it. You take that time to work on 10a in particular, but 10b if you get stuck. Okay, but that's it from me. Hopefully I'll be seeing you soon. I should be in whenever your next class is after Monday. But that's it from me. Good luck, have fun, and I'll see you all in next class.